My name is Pierre Seguin, CAD instructor and support staff for the Engineering Graphic course at the Royal Military College of Canada. This presentation will cover the improved method which allows producing drawing at the conventional 30, 45, and 60 degree oblique angles. I should remind the people that SolidWorks is used for all the methods. The explanation in the presentation might work on other platforms as long as the software allows at least configurations and extrusion along vectors. If it can also do offset from surface, up to surface, as well as extraction of intersection curves, it is even better. The configuration for the oblique projections will be deformed by extruding along a vector, and both the oblique and normal should still match. But this time, it could be done in a more conventional way. To have enough room on the sheet, the object that we model is again about 110 mm wide by 100 high by 120 deep. On the front plane, a sketch of two lines is drawn. This will control the angle and the receding line ratio. The length of the slanted line is a constant number that will be the same for all oblique configurations. It is not an intuitive value, but once it was found, it worked perfectly. A plane normal to the end of the slanted line is created, and a horizontal line is sketched on it, then dimensioned to a constant length of 100 mm. Another reference plane is constructed between this line and the origin. On this plane, a line joining the endpoint of the 100 mm line to the origin is drawn. This will be the projection guideline. The sketch is closed and a new one for the extrusion vector is started on the same plane to draw a line at an arbitrary angle. Then it is set to be 90 degrees from the slanted line created in the first sketch and made equal to the projection guideline from the previous one. This sketch will be named extrusion vector. The default configuration should be renamed normal. The suppress feature option should be clicked off and three other configurations created. The suppress feature option must also be off for all of them. The next step is to right-click on the angle of the first sketch and choose Configure Dimensions, which will bring up the table where the angle values will be changed. It is now the turn of the extrusion vector angle to be configured. The normal will be left at 90 degrees, but all the oblique variations will be set at 60 degrees, which will align the extrusion vector with the projection guide. Switching in sequence through the oblique configurations will show the change of angle, but in the normal, a collapsed structure with the extrusion vector pointing at 90 degrees from the front plane will be displayed. The system is now ready and can be saved as a base to start other oblique part files. After saving the system under a new name, the sketch of a rectangle is drawn on the front plane and extruded a blind distance as we would conventionally do. It is also important to include the extrusion vector sketch as the direction of extrusion. As this feature exists in all the configurations, when we switch to one of the oblique, the system is automatically applied, showing an immediate deformation, which after going in front view orientation, confirms that we have an oblique projection. Continuing to cycle through the other configurations shows that they are all adjusted to the proper angle, from normal to 30, 45, and 60 degrees. Furthermore, a drawing will confirm the angles, the true length of lines in the front orientation, and the half length of the receding lines. Feature can be added directly in the oblique configuration. As in the original method, a sketch with two regions has been made on the front face and the rounded extrusion has been cut through all. For the direction, any of the receding line can be used, as we could see in the display of the second cut. Here, instead of extruding to a reference plane as in the original method, a blind distance can be used. The result can be seen on the model as well as on the drawing, which confirms that all the configurations have the same cut. It is even possible to draw on the side as long as the horizontal relations are avoided and replaced by parallel ones. Be aware that dimensioning between entities doesn't work reliably anymore, so location dimensions must be applied to a construction line. Since the sketch is on the slanted face, a normal extrusion direction won't do the job. Instead, any edge being horizontal on the front face can be used. After the cut is displayed, the result is confirmed on the drawing for all the configurations. After verification on the answer sheet, I realized that the depth of the groove is wrong. So the dimension can be modified normally, and the change is updated everywhere, including the drawing. The part has an inclined surface at the front and an oblique surface on the left. As the oblique surface is the trickiest, I will use it as an example. In the oblique configuration, a first line is sketched on the top surface and its length dimensioned. This is important to remember as point-to-point might cause some problems. A second line is placed on the front face and again its length is dimensioned. The next step is to create a reference plane through 3 points. I change the point of view of my part to see the left side and can verify that the end of the sketch doesn't interfere with the selection of the back corner vertex. After selection of the endpoints of both sketch lines, the operation is completed. With this plane, I did a surface cut which will produce the expected oblique surface, a fact confirmed in the drawing of the 3 oblique views. At this point, most of the basic rules have been covered and a few more steps would complete the part.